Okay, for our second part of our lesson on about lines cut by a transversal, we're actually going to be finding measurements. So in this first example, they tell us the measure of angle 3 is 55. And as you can see, that angle is between the two parallel lines. And how I know these lines are parallel, these little red arrows here point in the same direction, showing that they're parallel. It says which angles are supplementary to it, and how do you know? So let's start off with something really simple. Angle 2 and 3 are supplementary because they are a linear pair. Or what we call supplementary angles. They're side by side. Now, based on that, at an intersection of 4 angles, you would have 2 sets of linear pairs. 2 and 3 would just be one pair. The other direction would be 3 and 4. For the same reason, they're a linear pair. Now, that's what we already know. Now, I know 3 and 1 are not supplementary because they're the same size angles. And for that to be true, they'd have to be 90. And they're not because it's 55. So let's go back now to angle 3 and look at it from a different perspective. Another kind of angle that we have is called same side exterior and same side interior. And since our two parallel lines have angle 3 between them, that means it's on the interior. So if I'm on the same side of my transversal, I would have to have angle 8 to be the other angle to add up to 180. So angle 3 and angle 8 are what we call same side interior, or we could call that, there is 2 names for this one. It could be called consecutive angles. Consecutive interior angles. So there is another pair of angles. Now, angle 3 cannot be compared to angle 5 in supplementary wise because 3 and 5 look the same size. So that will not work. 3 cannot be compared to 7 because 3 and 7 are both in the bottom right corner, so that makes them corresponding. Now, 3 and 6, they would make a supplementary set because one's obtuse and one's acute, but I have no relationship that we have learned to have one on the outside and one on the inside in different locations to be supplementary. So that is not one of our how we know, although they probably are supplementary. I cannot prove they are supplementary by just looking at the picture. I would have to actually do a proof for that. So I see 3 pairs of supplementary angles with 3 in it. 2 of them are side by side with 3, and one of them is our same side interior of the transversal type rules. So let's look at another example. It says, what is the measure of angle 3 and 4? Which theorem or postulate justifies each answer? And the justification here would be the name of the angle. So first of all, I'm given 105. And when I look at 105, it is between these 2 parallel lines and on the transversal M. So I look for is 2 or 4 on that same transversal, and 3 is. So since 3 is on that transversal, let's look at the location of the 105 and the 3. First, they're interior. Second of all, they're not on the same side of the transversal. One's on the right side and one's on the left. So angle 3 will be 105 because it's an alternate interior angle pair to the angle 105. So that is how you can get that measurement. Now it says get angle 4. So in order to get angle 4, I might want to look at a different pair of lines. So let me erase all of this and try to find what does angle 4 touch that the 105 touches. So this is the transversal that 105 and angle 4 are on, and here are the two lines that they are related to. So first of all, they also are on the interior, but they are not the same size. That's very obvious from looking at them. They are on the same side of the transversal between the parallel lines. So therefore, angle 3 would have to, not angle 3, angle 4 would have to be 180 minus 105 or 75 degrees because they are supplementary to each other because they are same side interior angles. So that's what they were wanting you to do on this picture. So now we have a much larger picture. And what I'd like you to be able to do is to go around the picture and find out how many angles can you name as a pair where angle 1 is one of the two in the pair, and find the measure of all the angles in the picture that you can find with angle 1 first. For example, angle 1 and angle 2 are supplementary. Therefore, if angle 1's 100, then angle 2's 80. So I could say angle 1 and angle 2 are supplementary. So you can name the angle pair and then name the angle that you're finding the measure of and tell how much it is, whether it compared to the other one. And I want you to try to compare every time to angle 1. So I could do that same thing with angle 1 and angle 4. I could say they're supplementary, and that makes the measure of angle 4 80 because angle 1 is still 100. And also at that same time, you could talk about which lines are parallel. For example, you could say AB is parallel to CD is cut by transversal line S, and list everything you know about line S as transversal first. So now that we've done those two, let's focus on angle 1 and compare it to angle 3. Now angle 3 is across from it at the same intersection. Therefore, angle 1 and angle 3 are vertical angles, and that makes the measure of angle 3 100. Now you can continue around the picture comparing angle 1 on the same line. Let's go to angle 5. They're both in what we call that top left position. One is on the exterior and one is on the interior of the two parallel lines. So therefore, angle 1 and angle 5 are corresponding angles. And that makes you the measure of angle 5 100 because corresponding angles are always equal and they look equal. So let's move to the next angle, angle 6. Now angle 6 is alternating with angle 1, but one is outside and one is inside. And we don't have a name for alternating angles, that they're in different locations compared to the parallel line versus exterior interior. So I'm going to have to come back to angle 6 in a few minutes because I can't compare it to angle 1. So let's go on and compare it to angle 7. Now angle 7 is outside, angle 1 is outside, and they're alternating. So angle 1 and angle 7 are alternate exterior angles. So that makes angle 7 100. So now let's move to angle 8. Now angle 8 and angle 1 definitely do not look the same size. Not only that, but angle 8 is on the same side of the transversal as angle 1. And they're both outside of these two parallel lines. Whoop. They're outside these two parallel lines here. And so therefore, that makes them same side exterior angles. So angle 1 and angle 8 are same side exterior angles. And so the measure of angle 8 has to be 80 to go with the 100 to make it add up to 180, because same sides always make 180. So we've done all of them on that transversal except for angle 6. So let's go back to angle 6 now. Since you cannot compare angle 1 to angle 6, you could choose any angle you prefer to compare it to. For example, you could do 6 and 8 are vertical. You could do 6 and 7 are supplementary. You could do 6 and 2 because they are corresponding. You could do it with 3 because out of all of those angles, you know everything but 6. So you can compare it to anything. I think I'm going to compare it to 2. They're corresponding. And the measure of angle 6 would be 80. So I have done half the angles on this picture. So now I'd like you to stop the video and look at the other half. And I'd like you first to focus on the fact that S and T are going to be your two parallel lines. AB is going to be your transversal, so that you can get one of the angles up here at 9, 10, 11, and 12 from angle 1, and see how many of those you can get from angle 1. And then once you've done that, you can work on T being the transversal. You've got to get one angle over there in order to be able to do all of them like I just did this side. So focus on the fact that you want to try and compare to angle 1 first, being cut by this transversal on these two parallel lines, and compare to angle 1 and try to get 9, 10, 11, or 12, just one of those angles. And then work your way around the picture and do exactly what I just did with the rest. Alright, so stop the video now and do that. Alright, you're back. So now, I'm going to compare angle 1 and 9, because I think that's a good choice. Angle 1 and angle 9 are both in the top left position. That makes them corresponding. So the measure of angle 9 would be 100. Once you have done that, you would want to also state that that is true because line S and T are parallel and they are cut by the transversal AB. That's the only one you need to get off of that particular one from those two parallel lines in order to work the rest of the question. But you could continue on those two parallel lines if you wanted to, because you could move your angle here and move to 10 and say angle 1 and 10 are same side exterior. And so since they're same side exterior, angle 10 would have to be 80. Then you can move your picture and say, well, I'd like to compare 1 to 11. Those are alternate exterior angles. And so therefore I could compare that and figure out that 11 is also 100. But I cannot compare 12 to 1 because one's inside, one's outside, and they're not in the same position. One's in the bottom left and one's in the top left. So that's why I thought it would be best for you to switch your picture now and work with the other transversal and the horizontal parallel lines. Because after you get 9, if you focus on this line right here, and you've got 9's 100, you can work your way around this picture the same way we did earlier. For example, 9 and 10 are supplementary, so 10's 80. 9 and 12 are supplementary, so 12 is 80. 9 and 11 are vertical, so therefore that makes 11 100. 9 and 13 are both in the top left or corresponding. That makes it 100. You also could look at 9 compared to 16 because they're both outside and on the same side of the transversal. So that makes 16 80 because they have to add up to 180. I could also compare 9 with 15 because 9 and 15 are alternate exterior angles, so that makes them add up to, add up, but equal, or both are 100. But I cannot compare it to 14, so then I have to choose some other angle to compare to 14. For example, I just found 15 was 80, so I just found 15 is 100, so our 14 would have to be 80 because they're supplementary to each other because they're a linear pair. So you always end up having one angle that you can't compare to all the others, and you have to get it in a different way. Now, on this last slide, we are going to have to name the angle that is marked and which parallel lines and which and also which transversal might be helpful as well, that justify that it makes them parallel. So these two angles are on this line, and they are cutting across these two parallel lines. So we're looking at, this is the top right of those intersections. One's outside the parallel lines, one's inside. That automatically makes it corresponding. So our angles are corresponding. So line, let's use the symbols here. Line BE is parallel to line CG because it was cut by this transversal EG. So that's what I'm wanting you to do on here. So stop the video now and try some of these on your own. You cannot use all the lines in the picture. You've got to focus on which lines do those angles touch. Did you stop the video and try? Well, now it's time for us to check your answers then. So over here we have this line touches PS and QT touches that line as well, so that we can focus on these two angles. Those two angles, one's inside, one's outside, so again it's corresponding. The name of those angles being corresponding makes PS parallel to QT because they are corresponding angles, make parallel lines, and they are cut by the transversal PQ at those angles. Over here at these 45-degree angles, this is your parallel lines, and here is your transversal that cuts them. I think this is also going to be corresponding again. So we have the lines HR that is parallel to CA or AC. And last but not least, this line touches both angles. This line and this line touch those angles. Again, they're corresponding because they're in the bottom left corner. But the lines that are parallel are KR is parallel to MT. And it's cut by the transversal JM, or you can use any letters off of that picture. You could even use KM if you wanted to prove that they intersect. So that's how you justify it. You tell the name of the angles that are formed, and you tell which transversal is cutting those parallel lines. Alright, that is the end of our lesson for 3.1, so now you can start your classwork.